So we said that a Riemann sum is our way of using sigma notation to add up an estimate of the area under a curve by adding up rectangles, right? And we said that we're going to add up to find the areas of the rectangles. It's just going to be the height of the rectangles, which is the value of the function, times the width of the rectangles, which is going to be delta. Technically, it's delta x sub I. Delta x sub I is the width of the ith subinterval, but we made a huge, we adopted a convenience. We said that we're just going to slice ours uniformly. So delta x sub I, we're just going to call delta x, which is just the width of the area divided by the number of rectangles. Okay, so that helps us a whole bunch. The other thing we said was when we want to calculate the height, and remember, this is telling us the height, and this is telling us the width. The value of the function that we're going to choose is always going to be the right edge. That's going to make life much, much easier. So c sub I, we'll always just let that be x sub I, which is a plus I delta x. So our Riemann sums then get much easier. Our Riemann sums just look like the area of n rectangles is approximately equal to, because we're doing rectangles, right? It's not exact unless we take a limit, which we'll get to, is just going to be the sum of the height will always be just f of a plus I delta x, right? And the width will always be delta x, where what's delta x equal to again? B minus a over n, right? The width of the area divided by the number of rectangles. And we're just summing this as I goes from 1 to n. Okay? All right, so let's look at a couple sample problems. Like these are the kinds of things you'd be looking at on your assignment. Okay, this is one where n is only equal to 4. So we're not going to use any sigma notation or anything. We're just going to add these things up, right? So we've got this function f of x equals cosine of x minus pi halves. And I purposely picked a really hard one. But you're going to use a calculator to evaluate these functions anyway, so who cares how hard it is? On the interval from pi halves to pi. So if n equals 4, what does that make delta x? How would I calculate it? Let's always start general. What's our formula for delta x? Okay, so in terms of b's and a's and n's, what is it? B minus a over n, sure. So what's our b? Okay, pi, there you go, good. So it's pi, isn't it? Good. So pi minus a is pi halves, everybody agree? So I get pi minus pi halves over n, which is 4. Well, that's just pi halves divided by 4, which is what? What's 1/4 of pi halves? Pi eighths. So our delta x is pi over 8, right? Okay, so now when they ask for the grid points, what in the world do they mean? Grid points, that is, some textbooks would refer to the grid points as just the important points on our interval, right? So we just want to write down what are the ends of our steps, is how we talked about it, right? We start at A, and then we just take steps of width delta x. We're only taking 4 steps. So we just want to know where are we starting and what are the locations of each step. In other words, what's x sub 0, x sub 1, x sub 2, x sub 3, and x sub 4. So what would x sub 0 be? Pi halves, that's A, right? X sub 0 is just A, which is pi halves. What's x sub 1? Everybody, how are we going to get that? What's x sub 1? Yeah, right? That's just going to be my first step. So if I started at pi halves and delta x is pi eighths, what is it? 5/8 pi, right? Pi halves, plus pi eighths, right? That makes sense? 1/2 pi plus 1/8 pi is just 5/8 pi. What's x2? 6/8, which would be what, 3/4? 3/4 pi. What's x3? And what's x sub 4? That's just b, isn't it? Because we reached the end of the line. We only n is 4, which is pi, right? So those are our grid points. Okay. So let's calculate a left sum. Okay. What's our left Riemann sum? So we'll call this L of 4 because we're adding up 4 rectangles. Okay, well, we just have to get a height and a width for each of those. What's going to be, how do I calculate the height of the first rectangle? What's it going to be? F of what? Tell me, I want the location. What's the left edge of the first rectangle? X equals what? Pi halves, right? The left edge of the first interval is where we start, isn't it? Everybody agree? Okay, where we start defines the left edge of the first rectangle. The right edge would be where we would be after one step. So everybody agree that would just be x sub 1. Okay, so f of x sub 0, which is just, he won't even write that. It's just going to be f of pi halves. What's the width of all our rectangles? Pi eighths, right? So there's our height times our width, right? Okay. There's the first area. What's the second rectangle's area going to be? Where do I calculate the height? F of what? 5/8. Good. Okay. So 5/8 pi is going to be the left edge of the second rectangle. Okay. What's the width of the second rectangle? Pi eighths. Okay, third rectangle. We're going to evaluate the function at 3/4 pi times the width. I'm not even going to ask. You're going to tell me, when I do ask, you would just tell me pi eighths. And then finally, the last one, the left edge of the fourth rectangle would be f of 7/8 pi, good, times pi eighths, right? So if I plug all that stuff in, there's my formula, right? There's f of x. So if I plug that stuff in, let's remind ourselves what that is. So f of x, I'll write that down here. Cosine of, oh, there it is right there. X minus pi halves. Okay. So if we add that stuff up then, that's just going to give me cosine of what? What's f of pi halves? Cosine 0, yeah. Cosine 0 times pi eighths plus, what's the second one going to be? Cosine of, what's 5/8 pi minus pi halves? Pi eighths, good. Third one, f of 3/4 would be cosine pi fourths, good, times. And then finally, cosine of 7/8 pi minus pi halves, 3/8 pi, there you go. We would just plug all that in a calculator. That's it. So What is cosine of 0? 1. Right, so I get 1 times pi eighths. So pi eighths plus cosine of pi eighths. Who knows? It's just a calculator number, right? We would literally just put all this stuff in a calculator and add it up. That's the only way to do this. Okay? Makes sense? I mean, no one's going to expect you to know what cosine of pi eighths is, right? Plus whatever pi eighths times cosine pi eighths, whatever that is. Third one, cosine of pi fourths, we do know. What's that? Square root of 2 over 2. Yeah. Square root of 2 over 2 times pi eighths plus, and the last one, who knows? Cosine of 3/8 pi, that is not a unit circle number, so that's a calculator number. What's the question? How we got that? Oh, the trick? Here's the trick. Okay, so look, which finger is pi fourths? This guy, right? Okay, so we fold that guy. Well, because it's 0, pi 6, pi fourths, pi thirds, pi halves, right? Okay, so we fold that guy in, and you get the square, so that you get the square root of this over 2 is your x coordinate. Square root of 2 over 2 is your x coordinate. Y coordinate, square root of 2 over 2. Because that's just the way the trick works, right? It's always the square root of the number of fingers over 2. Yep, exactly. Square root of 3 over 2. Square root of 1, which is just 1 over 2, so 1/2. So if it were pi 6 or 30 degrees, right? The cosine of 30 degrees would be square root of 3 over 2, right? The sine, everything's over 2 always, yeah. Right? And then this would be, the sine would be 1/2. What if we did 0? Yeah, right, exactly. Because you always get, because the x coordinate on the unit circle is cosine, y coordinate is sine, right? So it's always giving you the cosine number and the sine number. Square root of 4 is 2. 2 over 2 is 1. How about that? So cosine of 0 is 1. Sine of 0 is square root of 0, which is 0 over 2 is 0. It works. Amazing, huh? Yeah, okay. So then we would just plug all that stuff in a calculator and get an answer. Everybody get that? That's just, who knows what it is, just some big calculator answer. Make sure you're in radians mode because you're using pi's, but that's it. Okay, what about now this will go really fast. The right sum, we've already done a bunch of the work. Yeah, the right sum, so r of 4. Okay, so what is the left edge of, or sorry, the right edge of the first rectangle? Is where? The right edge. It's going to be, okay, good. So it's going to be 5/8 pi, right? Okay, so look, 5/8 pi. What do you know? That was wouldn't you agree the left edge of the second rectangle is the same as the right edge of the first rectangle? Because if we were to look at our picture up here, what did we just do with our left sum? Didn't we just do this? So we started at pi halves. Here's x sub 0. X sub 1 was 5/8. X sub 2 was 3/4 pi. X sub 3 was 7/8 pi. And x sub 4 was pi, right? So then we said that the height of the first one was this guy. So there's the first left rectangle. Here's the second left rectangle. The height was determined at 5/8 pi, and the width, of course, is pi eighths. So there's the second one. Everybody see that? Third one, the height was determined at 3/4 pi. Fourth one, the height was determined at 7/8 pi. So there it is. So is the left sum in this case an overestimate or an underestimate? Good. How come it's an overestimate? because the function's decreasing, right? So the highest part of each rectangle is going to be the left edge, okay? What about the right sum? Okay, well, the right edge of the first rectangle is the same as the left edge of the second rectangle. So what do you know? Those two are the same, aren't they? Right? The right edge of the second rectangle is the same as the left edge of the third, so those two are going to be the same. The right edge of the third is the left edge of the fourth, so those two are the same. And then what about the last right rectangle? What's its height going to be? 0. Yeah, look, because the value of the function at pi, which is the right edge of the fourth rectangle, is 0. So I get 0 from that one, right? So look, this helps us out. The right sum then is just going to be this guy, right? Plus there's r sub 1. There's our second right triangle, right? Does that make sense? Here's our third one. And our last one is just 0. Everybody get that? Okay. So we would just get those, that would be it. Pi eighths times cosine pi eighths plus pi eighths times square root of 2 over 2 plus pi eighths times cosine 3/8 pi. Okay, what about the midpoint sum? The midpoint sum, if I add those up, what's going to be the area of the first midpoint rectangle? The width is just pi eighths, but where am I going to calculate the height of the first midpoint rectangle? What x value would I plug in? It's going to be, where in that first interval would I be evaluating the height? Yeah, it's going to be, it's really inconvenient. It's going to be the middle of that first section, right? So where is that? Well, what's halfway between pi halves and 5/8 pi? Unfortunately, it's 9/16 pi, right? That's really inconvenient because we're only going to add a 16th instead of an eighth, right, to pi halves, or average the two. So that's really inconvenient. So the first one is going to be our width of pi eighths times cosine of pi minus, was it? Oh, no, never mind. It was 9/16 pi minus pi halves. So that's just 1/16 pi, right? Did you get that? Give me thumbs. That makes sense. Excuse me. Okay, what about our second midpoint? Second midpoint would be, the width is pi eighths. Where's our second one going to be? Yeah, right. We're going to only go over 1/16 pi from 5/8, which is just 10/16, right? 10/16 pi plus one more would just be 11/16 pi. Subtract pi halves, and so on. Make sense? So we would just, we'd have to just calculate a number for each one of these, and they're very inconvenient, right? But we just would calculate a number value for each of these four and add them up. That's it. Okay, everybody good with that? So we just kind of, these are a pain, but when we have a small number of rectangles like that, don't bother trying to set up sigma notation. Just calculate them. Just calculate all the individual areas and add them up. Okay, so then we'll abandon that. We don't want to spend more time on that. Here's the other kind of question. You get two of these on that third assignment that I sneaked in before the 3-day weekend. So this is one where we are going to actually get an exact area, because we're going to take a limit as n goes to infinity, right, to get an actual perfect answer. Okay. So how do we do that? We're going to take a limit of a Riemann sum. Now this sets us up for the stuff that we're going to get into tomorrow, which is the new stuff, which is the really good shortcut stuff. So you always want to start general, right? So the actual area, let's start as general as we can get. The actual area under the curve is equal to the limit of the Riemann sum, right? You guys tell me, what's the most general form of the Riemann sum? The sum of what? F of, right, but what is that? What is our most convenient place? We always use the right edge. What is the right edge? X sub I, which is what? The right edge of the ith subinterval is what? There you go. A plus I delta x. That is just x sub I, right? So f of x sub I, and what's the width always going to be? So just delta x, right? We'll just call it delta x to keep things short. And we know in our mind delta x equals always b minus a over n. There you go. Okay. And we're going to sum that as I goes from 1 to, okay, but the sum goes from 1 to how many rectangles? N, right? The Riemann sum, we're going to always divide it up into n rectangles. So there's our Riemann sum right there. This part is the Riemann sum. But to make our answer exact, without taking a limit, it's never going to be exact, right? We did say that the larger the number of rectangles, the better our estimate. But if it's a finite number of rectangles, it's never going to be perfect. Everybody good so far? Does that make sense? To make it perfect, what do we take a limit of? N goes to infinity. Exactly. We take the limit of all that stuff as n goes to infinity, right? Okay, so for us here then, what would we get? So here's f of x. We know what f of x is. If we're going from 0 to 2, what is our delta x going to be? It's just b minus a over n, right? So what does that give us? Look at our interval. Yeah, 2 minus 0 over n, which is just 2 over n, right? Okay, our function is f of x equals x squared plus 4. So then we can start to plug in a whole bunch of stuff here. So our actual area is going to equal a limit of what? F of a plus I delta x. Well, a is 0, right? Everybody agree? So a plus I delta x, f of 0 plus I times delta x, well, that's just 2I over n. Everybody agree? Good? Give me thumbs. Does that make sense? Okay. Times delta x, which is 2 over n, right? Okay, we're going to sum all that stuff as I goes from 1 to 1 to n. So there's our Riemann sum, and then we're going to take a limit to get an exact answer as n goes to infinity. Okay, so we're just gradually getting more specific. Okay, well, what is our function? X squared plus 4, right? So then what is all this going to become? F of 2I over n. If f of x is x squared plus 4, what's f of hand? If f of x is x squared plus 4, what's f of hand? Hand squared plus 4, right? So f of hand, this is just going to give me hand squared plus 4, right? That's what all this stuff is giving me. Agreed? Okay. Times 2 over n. And by the way, what's hand? Just 2i over n, right? Oops. Oh my gosh. Red. There we go. Times 2 over n. We won't even go out any further than that for now. Let's just figure out what all that is. Well, what is the quantity 2i over n squared? If I square that, what do I get? What's the quantity 2i over n squared? 4i squared over n squared, sure, okay. So that's the same thing as, we'll call that 4 over n squared times I squared plus 4. And what are we doing with all that stuff? Well, we are taking a sum of all that. From 1 to n, right? Everybody get that? Okay. So if I'm summing up two terms, properties of sigma notation, if I'm taking a sum of this plus that, what can I do? Separate them, absolutely. Let's separate them. So we're going to write these as separate sigmas. So here I get the sum of 4. Now what about this one? If I'm summing up this first part, what can I do with the 4 over n squared? Because the sigma only cares about i's, right? So I could pull that out front too. Like I could pull this stuff out in front of the sigma. And I've just got the sum of I squared from 1 to n plus the sum of 4 from 1 to n. Okay, and then once I get all that stuff, I'm going to end up taking a limit. But let's not even worry about the limit part. Oh, I forgot the 2 over n here. That should come out front of this guy too, shouldn't it? Everybody see that? I've got inside, let me back up just a little bit. What about this 2 over n? This 2 over n is getting distributed to each of these things, isn't it? Right? So that means I'm also going to get a 2 over n out in front of each of these sigmas also, right? Everybody see that? Gosh, I feel like I should write this as, am I skipping too many steps? Are we feeling okay about this? Okay, so I'll color code this. So this 2 over n out here is going to get pulled out in the front of each of these also, right? Okay. Now you may or may not remember this, but we've got our sigma, our summation formulas. Can you guys remind me real quick, what's the sum of C as I goes from 1 to n? Cn, yeah, it's Cn. Okay. What was the sum of I as I goes from 1 to n? Remember that one? Yeah. N times n plus 1 over 2. You're right. Okay. What was the sum of I squared from 1 to n? Double dog dairy. This is, it's over 6. Good. What's on top? Times, what's the third one? This is a tough one. This is the hardest of all of them. 2n plus 1. Yeah. And then the last one, the sum of I cubed as I goes from 1 to n. What's it over? Remember? It's over 4. I think this one's easier. It's just n squared times what squared? N plus 1 squared. Okay. What are the ones we need? Top one and third one, right? Because look, we've got a sum of an I squared and we got a sum of a C. Okay. Everybody see that? Okay, so then what's all this stuff? Let's make it green. What's all that stuff going to become? Well, it's just that, right? So all that stuff just becomes n times n plus 1 over 2. Out in front, I've got that stuff, which is just 8 over n cubed. Everybody agree? Okay. Oh, you're right. I did the wrong one. Yeah, I was about to say that didn't work right. Let's go back. So n times n plus 1 times 2n plus 1 over 6 times 8 over n cubed, right? Okay. If I multiply all that stuff out, if I FOIL that, I'm going to get 2n squared plus 3n plus 1 times another n, right? Which just increases the powers by 1. So all the green stuff is just going to become this. It's just going to be 2n cubed, right? If I FOIL that, n times 2n is 2n squared times another n. It's 2n cubed. If I FOIL out the cross terms, I'm going to get 3n times another n is 3n squared. And then the last part would be 1 times n. So I get that stuff times 8 over n cubed. Everybody agree? Okay, and if I were to, I could do a little cancellation here. 8 over 6, that becomes a 3, that becomes a 4. And if I were to distribute everything through then, what's that going to give me if I write that as separate fractions? 2n cubed over 3 times 4 over n cubed is what? 8 thirds times what? N cubed divided by n cubed. 8 thirds, right? Okay, what about the middle term? I'm going to get 3 times 4 is 12 over 3 is just 4, right? N squared over n cubed. 4 over n, right? And then here I'd get 4n over 3 divided by n cubed. Puts an n squared on the bottom. Everybody good with all that? Okay. Fortunately, this other one's a lot easier. Right? When I add this guy up, that's just 4n, right? Everybody agree? Okay. So then we just get this plus sign, and then we get plus, we had our 2 over n, and then everything in the purple box just becomes 4n. So that just becomes 8, doesn't it? The n's cancel. Everybody buy that? Okay. So we just get plus 8 plus 8. Okay, so that took care of all this stuff. But don't forget that we're still taking a limit of all this as n goes to infinity, right? Yeah, so then clear down here now, our actual area is going to equal the limit of all that stuff as n goes to infinity. Well, what good thing happens there? Everybody agree? When n goes to infinity, these terms right here, because they have n's in the bottom, are going to 0, and we just get 8 thirds plus 8. Well, that's 8 thirds plus 24 thirds, just 32 thirds, right? So that's our exact answer. How about that? Okay. is exactly 32 thirds. Yeah. That is crazy. Okay. All right. Finish that assignment up.